Hi everyone. Today we're going to talk about the Triangle Proportionality Theorem. So the Triangle Proportionality Theorem says that if you have a triangle, such as our large triangle QXY, and you've got a line that's parallel to one side of that triangle, so that line RS is parallel to the bottom side of our triangle QXY. And if that line RS that's parallel to XY is intersecting the other two sides of the triangle, so intersecting side QX and side QY, then it's going to divide those sides proportionally. Now remember, proportionally just means that when we divide the two pairs of sides, they should give us the same value or the same scale factor. Ratios of pairs of corresponding sides should be the same if the shapes are proportional. Now remember, when we set up a proportion, we need to keep our corresponding pieces consistent when we set that up. So to help you visualize this, I want you to consider these two different shapes. Consider your top triangle QRS, and we're going to compare that to the trapezoid beneath it, RXSY. So I like to color code my shapes like this. And now when I'm taking pieces from the green shape and the yellow shape, I want to stay consistent with them when I set up that proportion. So say I want to put my green shape pieces on the top and then my yellow shape pieces on the bottom. Or you could set up maybe your green pieces on the left and your yellow pieces on the right. It's really up to you. I prefer to do green on top and then yellow on the bottom, but you can feel free to do it the other way. So the theorem tells us that the sides should be proportional, meaning let's say we wanted to compare the left side of each shape. So that would be QR for the green one and RX for the bottom one. And that has to be proportional or give us the same value when we divide the right sides of these shapes, or QS and SY. So we're going to use color coding a lot in this lesson to help us keep consistent with our fractions. Notice that we have green shaped pieces on the top and yellow shaped pieces on the bottom. And then we did our left side pieces in blue. We want those all on the left fraction. And our right side pieces in red, we want those on the right fraction. Again, if you were going to set this up a different way, it might look something like this. Now, we can flip our rule around or give the converse to it, which says that if we know that those pieces are proportional, then the lines have to be parallel. Okay, let's try and use this rule to solve some problems. So again, I'm going to color code to keep myself from getting mixed up. And we're going to compare this time, let's say like that top right diagonal side of each shape to the bottom side of each shape when we set up our proportion. And then we can cross multiply that proportion and set up an equation that can be solved simply for x using division. Now again, you may have set your fraction up different from me. Maybe you put those green pieces on the left and the yellow pieces on the right. But once you cross multiplied and you got down to your equation and my equation should be the same, regardless of how we set up our fractions, as long as we were both consistent when we set those fractions up. Okay, let's try this for number 3. And then you guys are going to try those even ones on your own on your notebook paper. So this time, if we color code our our triangle and our trapezoid, and we compare the left side of each of those shapes to the right side of each of those shapes, we notice that we're missing the value for that right diagonal side of the triangle. But we do know the value of all the way from the apex of that triangle all the way down to the bottom right corner of our trapezoid. So we can take that full length value, subtract out the trapezoid value, and that gives us our small triangle side value. Now we're able to set up our proportion and solve for the variable. Okay, let's try this one more time, and this time we're going to throw in some algebraic expressions. So again, we're going to color code to keep ourselves organized. And then we're going to compare the left side of each shape to the right side of each shape. Once we've got our proportion, we can cross multiply that proportion and solve for the variable. Now here, when you cross multiply, you want to be careful that you make sure that you distribute that 25 into both the x and the 7. Okay, at this point, I want you to take out your notebook paper. You're going to name this lesson 7.4, proportional lengths. You're going to put your name on it, and then you're going to try numbers 2, 4, and 6 on your notebook paper. Pause the video here and press play again to see the solutions. Okay, so here's the solutions for numbers 2, 4, and 6. And again, I color-coded the diagrams to try and keep us nice and organized. Now, you can get some decimal answers. A reminder about decimals, if your answer is exact, meaning when I divided 147 by 6, I got exactly this number in the calculator. I didn't shorten it or round it. It's fine to put that decimal down. If you need to shorten or round it, remember that you want to then show your equal sign as a squiggly equal sign instead of a regular equal sign, and that would mean approximately equal to. This one was exact though, so we're going to leave it. And in number 6, make sure that you distributed into both sets of parentheses in that first step of cross multiplication. Okay, now we're going to get into the converse of that theorem. So remember that the converse, if we flip the theorem around, it says that if our sides are proportional, then the lines must be parallel. If we find that our sides are not proportional, then we're going to know for sure that the lines are not parallel. So when they ask us to determine if MN is parallel to JL in each diagram here, all we're going to do is set up our proportions and solve for each and cross multiply. And we want to see that when we cross multiply, we get the same value on both sides. If we do get the same value on both sides, yes, the shapes are proportional, meaning that the lines MN and JL will be parallel. If we find that those sides are not proportional, when we cross multiply we get a different value, then line MN will not be parallel to line JL. Okay, why don't you try number 9? Determine if line MN and JL are parallel by setting up a proportion and solving. Notice that you need to find the distance of JM when you set up your proportion. Pause the video and then press play again to see the solution. Okay, here's your solution. So I found that the lines were parallel. First, I had to subtract the 54 and the 24 to find the distance of JM. Then I was able to use that to set up my proportion. And cross multiply, we find that they give us the same value. Therefore, line MN is parallel to JL. Okay, we're going to build on that theorem a little bit now. So instead of just having a triangle that has an extra line down the middle, now we're going to compare 3 or more parallel lines that are split by 2 transversals. And when this is the case, if all 3 of those lines are parallel, then those transversals are splitting the spaces in between those parallel lines into proportional spaces. And this time, again, we're going to color code to keep ourselves organized, but we've got 2 trapezoids here. So we've got the top green trapezoid and the bottom yellow trapezoid. And we're going to compare, again, those left-hand sides, AB and BC, to our right-hand sides, WX and XY. So it's really important here, again, that you stay consistent when you set up your ratios. We're going to practice that in example 10. So this is where our color coding really helps a lot. We're going to stay with our orange on top, green on top and yellow on the bottom. And I'm going to color code my diagram to help me out. So I noticed that I have both of the yellow pieces. Let's look at what they are. So that's giving us CF and DB. And for the green piece, we've got GC. Now we want to make this fraction match up. So if we used GC, the left side of this top triangle, and we're comparing that to CF, the left side of the middle trapezoid, and that means when we switch over to the right side of that trapezoid, we got to compare that to the right side of the triangle to stay consistent. That's going to give us our match. So to finish this fraction or this proportion, we would put GD in the numerator. Okay, let's try that again. So I'm going to clear off my color coding here. And now I'm looking at green on top, yellow on the bottom. We're going to compare. Now notice that we have both these green pieces now. So I'm looking at F to G and F to B. So I'm looking at sort of a triangular shape here. look at this triangle from G to F to B. And we want to compare that. All we've got so far is AG. We want to finish the pattern here. Well, it looks like we're comparing the left-hand sides, so from F to G and from A to G in our first fraction, and then we're given the bottom of the green triangle, so we're going to have to finish that out with the bottom of the yellow triangle, or side AE. Okay, one more time and then you try it. So we'll clear off our color coding and we'll start again. Green's on top, yellow on the bottom. I got both of my green pieces, so I'm going to highlight those. I've got one yellow piece, and I want to make the other yellow piece match. So I compared bottom green to bottom yellow in the first fraction, and then I've got the right side of my green, so I'm going to compare that with the right side of the matching yellow there. So that's going to give us GD. Okay, pause the video here and see if you can try examples D, E, and F on your notebook paper. Press play again to see the solutions. Okay, here's your you try solutions. So I'm going to quickly show you the color coding I used for each one. Here's how I set up 10D. This is how I set up 10E. And this is how I set up 10F. Okay, now we're going to use that same idea of setting up these proportions to find each of the missing lengths that were given to us in the diagram below. So we're finding 4 different lengths, and I'm going to go ahead and give them different variables. So when I'm setting up my diagram, it's easy for me to solve or see which pieces I'm looking at. So I'm going to go with an X, a Y, a Z, and let's go back to a W. Now, when we're solving each of these, we have choices of how we want to set up our proportions. Again, we want to be consistent with it, so let's stick with that green on top and yellow on the bottom. And when we choose our pieces, all we need to do is make sure we stay consistent. Now, I noticed that that X that I'm trying to solve for is part of that middle trapezoid. So we've got to use the middle trapezoid in some way. Let's compare that to, let's say, the triangle on top of it. We're looking for the right-hand side of that trapezoid, so we're going to have to compare it to the right-hand side of the triangle on top. But then we can choose another pair of sides that we know for those shapes, like the left-hand side of each shape. Now we easily cross-multiply and solve for the variable x, or the length of side BC. Okay, let's clear away our color coding so we can recode for the next diagram. Again, we want to stay consistent when we set up our fractions, so let's go with green on top, yellow on the bottom. And this time that side FC we're looking for, that was our side Y. So that's the bottom of that yellow trapezoid, meaning we have to compare it to the bottom of one of the other shapes. Now, we only have the bottom of that large trapezoid, so we're going to have to choose that guy down there. Now we're going to set up consistent pieces, so that bottom to bottom on one side of our fraction, and we have to compare that to pieces that we know, like maybe the left-hand side of each of those fractions. As before, cross-multiply and solve for the variable. Now in this case, we got a decimal value that was not exact. I got 10.71428571 before my calculator cut it off and stopped showing me, so there could have been more digits. Since I rounded my answer here, I'm using the squiggly equal sign to show that it's approximately equal to and not exactly. Okay, let's try one more, example C, and then you guys are going to try example D on your own. So again, we want to clear out our old colors. Let's stay consistent when we set up our fraction. So again, I'm moving my green on top, yellow on the bottom. And now this time I'm trying to solve for that side Z. So notice that Z is the bottom side of that top triangle. So I'm gonna have to compare that to another bottom side. The only other bottom side that I had that was given to me was that 15. Even though we just found FC, we could use that value of FC that we just found. However, it is approximate. Remember, we rounded it. So if we use a rounded part, or a rounded piece, as we set up our next part, that means our next part is going to be more rounded. We're going to compound the rounding that already happened, which means we're getting further away from the true answer. So we're not going to use that side FC because it's approximated, and we're going to use the exact side ED with that 15 at the bottom. Now again, we're going to compare bottoms of each shape. And we've got to choose another pair of sides that match up corresponding sides so we have the value for both shapes. So I'm going to use the left-hand side. Cross multiply and solve for the variable. Now notice that our value for z was the same as our value for y, and that was because we used the same pieces in our fractions or our proportion. And this is a perfect example of how you can see, even though those proportions were set up differently, they really gave us the same thing when we cross multiplied because we were consistent in our setup. So when we had 15 and y on the left, we still had that 15 in the variable on the left, but it was flipped upside down, meaning in our second fraction, if we can stay consistent with that and flip that one, we can see that we got the same equation because we were consistent in our setup each time. So even though they looked different, they were in fact the same, which is why you might get values that are, or solutions that are the same as mine, but maybe your setup wasn't quite the same. Okay, pause the video here and try example D on your notebook paper. Press play again to see the solution. Okay, here's your solution. So I chose to use the top triangle and the bottom trapezoid. I got exactly 8.4, which is why I didn't use the approximate sign here. I kept the equal sign. All right, let's apply that last rule to some more diagrams. We'll try the left two. You guys will try the right two on your notebook paper. So again, we're going to color code. I'm going to go with the green trapezoid and yellow trapezoid as we have been. I'm comparing the top slanted side of each of those shapes to the bottom flat side of each shape. Again, I'm subtracting the 32 and the 18 to find my missing space there on the bottom of that green trapezoid. And then I'm going to cross multiply and solve for the variable. Okay, let's do the same thing for 14. So again, I'm going to color code green trapezoid, yellow trapezoid, set up my fractions with that color coding, plug in my left-hand sides of each shape, and plug in my right-hand sides of each shape, and then cross multiply. Now when you cross multiply here, be sure to distribute the coefficient out front into each term inside of the parentheses. All right, you guys try 13 and 15 on your notebook paper, and then press play again to see the solution. Okay, here's your solutions. So now we're going to try one more before we finish for the day. This time we're comparing the distance that Charlie walked to the distance that you walked. So let's think about the paths that they tell us were taken in each of these examples. So they say first that Charlie walks from point A to point B. So he makes it along the bottom side of this triangle here. And then he goes from point B to point C. So then he goes up the left-hand side of the large triangle. Now, you, on the other hand, are going to walk directly from point A to point C. And the question is, how much further did Charlie walk than you did? So we're going to have to find the distance that you walked. We know all of Charlie's distances. They're given to us. But our distance, we're missing this piece here. So we're going to have to find that. And we're going to do so by setting up a proportion like we've been doing in the past. So I'm going to color code like we've been doing as well, again with my green and my yellow. So we're going to go with the left-hand side of each of those shapes compared to the right-hand side of each shape. Cross multiply and solve for x. So now we can see that Charlie walked a distance of 1,200 plus 300 plus 600 feet, or 2,100 feet, and you walked a distance of 500 plus 1,000 feet, or 1,500 feet, meaning that Charlie walked 600 more feet than you did. All right, great lesson, guys. Tomorrow you guys are going to do the practice worksheet that's attached here and turn that in on Google Classroom. Stay safe, everyone.